So before you even start integrating, what were the first things that you did when you saw this? Before you even started integrating, what kind of what did you think?
Whoa.
Yeah, I guess you want to expand it.
Yeah.
Probably can do that.
Whoa.
My suggestion though, before you even expanding is helpful, right? But you want to graph this function, right? You want to graph this function. So I want to graph it over to the side here. And it doesn't have to be very neat, just a rough sketch so I know what region I'm dealing with. In this form, right, can you tell what this is going to look like already?
If you use Desmos,
Maybe, yeah, if you use Tesla. What shape would it be?
Brownie.
It's a parabola and it's concave down because there's a negative in front of the whole thing. So I know it's a concave down parabola. I don't know the intercepts just yet. But this form here, the factorized form year 20, is really good for finding the x-intercepts. So I already know, Nick, can you tell me, what are the x-intercepts of this parabola here?
-1 and 2.
-1 and 2, you know that from this form. And notice that this negative in the front doesn't affect anything. You want to know what values of x will make y equal to 0. Those are the x-intercepts. And in this case, it's just -1 and 2. Okay. So I know the intercepts. I'm not too sure where, so I know the x-intercepts. I'm not too sure where the y-intercept's going to be. But if Keenan, if you expand this one out, it will really help.
Okay.
So what do I get?
2x. Negative 2x.
Okay, well,
If you.
negative 2x. That's wrong.
X.
Okay.
Oh, sorry.
Why
X
does this
squared.
stand
X squared.
out?
Yeah. X squared.
Yeah.
Minus 2x
Yep.
plus x
Plus x.
and minus 2.
Plus 2, yeah. You can combine the like terms and also expand out this negative. That's what I would recommend. So you get negative x squared. These two would be, that would just be negative x. But if you expand it out, you get positive x. And then that's going to be positive 2. Okay.
You know, I'm going to do that.
Also,
Isn't it negative then?
No, it's actually 2.
so if you expand out the bracket here, so you get negative 2x plus x, that would just give you negative x. Yeah. And then you multiply it by negative.
I didn't do that.
That's alright.
That would be 1.
So from this form now, what would the y-intercept be?
I do that to myself.
Y-intercept?
Yeah.
Oh, well, you go back to the first part and you figure it out through that.
Oh,
bit.
there's just so many different.
Oh wait, the y
I
is
Yeah.
just-
So we've got we've got the x-intercept here. Now this expanded form is really good for finding the y-intercept, right? Because if you let x equal to 0, that's going to tell you where the y-intercept is, and that's just clearly the constant there, which is 2. So you sketch your little parabola. So at this point here, I have made 2 folds of the parabola.
You can do your thing with
What's the thing image here? What's the question I'm trying to answer?
the area.
Area under the
Area.
curve
Bounds
bounded
of
by the x-axis, right? And that's this area here. So what did I need to do with my integrals? I have to construct them, right?
Yeah, put the S in.
What integral do I want though?
2 and -1.
Right. So I want the x values. 2 is my upper bound. -1 is my
Lower
That
lower
last
bound.
one's
Okay.
really
Now what's the function I'm integrating? It's this parabola here. My suggestion to you is, whenever you have a quadratic, or any function really, if you expand it out, it's much easier to integrate, right? Because you can treat these all as separate terms. In this form here, because they're multiplied together, it's much trickier to integrate. So my suggestion is expand it out, it's much easier to use this form here, okay? Okay, then it's just really simple, easy street. We gotta keep going. Nathan, gonna keep going?
Yeah.
Can you integrate this carefully?
You want me to integrate that?
Yeah.
So we substitute in the.
Just this primitive first.
Oh, you want me to find the primitive?
Yeah.
So it's going to be minus x3/3
Yeah, x cubed over 3.
Plus x squared over 2.
Yeah, or half x squared, x squared over 2.
Yep.
Plus.
Yeah, you wrote that one.
2x.
Cool.
Yeah.
And I've got my upper and lower bounds. Why don't you chuck those in the calculator for me? Correctly, hopefully. So when you evaluate, there's a couple of different ways you can do it. You can substitute to your calculator, or you can use that answer method that I taught you. But
The first part's 10/3.
Yeah.
And then
Minus
the second
minus
part-
7/6, and that will just give you 9/2 what? Units squared, right? Because the answer that the question that we're trying to answer here is how much area is under the curve. How much area is under the curve, right? Okay. Cool.